So we'll start the day with a keynote from someone I was very pleased to welcome there, and I was actually, jumping up and down when she actually accepted to come there. So I think most of you knows about Kate Gregory. Kate is a mentor, is a teacher, is an engineer. She has, I don't know how to say that, actually more than a tremendous, career and, things out there. I've been teaching C++ for quite a while, and I'm still looking at, coming up at the level of Kate at some point. Well, I still need, some style things and so on, but yeah, that should be okay. So Kate is from Ontario, if I'm not mistaken, and where she runs a consulting firm, something, yeah. And she will speak about emotion in codes and how it relates to what we are doing. So please welcome Kate Gregory.
Hello, bonjour. I won't subject you to my Canadian French. It's relatively rusty, and even if it was up to date, it would still be Canadian French, which I understand is a different language than French. It's kind of like England and Canada, were two countries divided by a common language. Same thing. And yes, I am from Ontario. I am from where the Raptors are from. And I was woken up on my flight here in the middle of the night by the whole plane erupting into cheers when the Raptors won. I usually come and talk about code. I think most of my talks have a lot of code in them. And for the last couple of years, I've been talking about how to make the code we write better. So obviously, our code needs to be fast. We are C++, that's what we do. It also needs to be correct, because if correctness doesn't matter, I can just write return 7, which is like super fast. And I'll outperform anything you write that goes to the trouble of calculating the correct answer. But for the last maybe 5 years, I've really been defining better as beyond that. So about being readable, understandable, enjoyable, pleasant, reassuring. And I've done quite a lot of talks about that. And I'm not going to stop. You'll still see talks about that. But this talk isn't actually about the code. Because in all that time, I didn't really think about the people who wrote the code. And especially about why they wrote the code. I've been paid to program since 1979. It's 40 years of reading other people's code. And I've said some things, to the air, not to the people who wrote the code, but to, like, what were you thinking? What's wrong with you? But they were only rhetorical questions. And recently, I decided they were actually worth answering. Maybe not the what's wrong with you, but the what were you thinking? Start thinking about the people who wrote the code I'm reading. Now, I want to take a side trip before I get into the code to talk about emotions. The first book I wrote was about internet programming, and this is where I learned this concept of an out-of-band interrupt. So if you're downloading like a really long file and it's going to take 20 minutes to download it, but then there's something has happened to make that irrelevant, the server can contact you on some other method to say, stop downloading that file, right? It's going to keep that communication channel open for 20 minutes, but it needs to tell you before then, hey, I've got some important information for you. That's what emotions are. That's exactly what they are from one part of our brain to the part of our brain that thinks. Here's a conclusion. Get out. This isn't safe. Something's really creepy and wrong here. And you don't have the spreadsheet worth of information about proving that it's scary and bad. You're just suddenly scared and feel like you need to leave. Or you can trust this person. Relax. This person is not lying to you. And again, you don't have a long, detailed list of why this is okay and warm and friendly and welcoming, but the conclusion has arrived. They are a distillation of intuition and experience. I was in this situation before, and someone started talking like this, and then later things were very unpleasant. So now I'm scared because I'm recognizing a pattern. We are such good pattern matchers. And I may not be able to list exactly what's making me feel warm and welcome or scared or angry, but the conclusion nonetheless has been delivered. And sometimes we act on emotions. We yell at people, we suddenly get angry in meetings, we say things we didn't think we would have said, or we trust the salesperson and sign the contract because they were so nice and reassuring. And other times we don't. We say, I know you're making me feel very warm and welcomed and friendly and like you're on my side, but intellectually, I'm not going to trust that. I think that's actually an act on your part. And I'm going to remain detached, and I'm going to argue and negotiate and not be swindled in this meeting that we're having. Some of us are very good at getting those signals. We feel scared. We notice that we're feeling scared. We think, we bring a little thinking into play, and then we can take an action based on this emotional signal that we got. Other people are not so good at it. They don't recognize emotions in themselves, or they don't necessarily recognize them in other people as well. And one thing I've discovered is that people who aren't super good at the emotional side of things say, it's not actually a useful signal. Nobody should be doing this. Using emotions to make decisions is lazy. It isn't rigorous. You're cutting corners, you're cheating, you're just jumping to conclusions without proper logic and reasoning it out. Where is your spreadsheet of numbers about why this is a good deal? You just say you think the salesperson seems trustworthy. Very often people will say to me, we don't do emotions in programming. As programmers, we don't have them. We don't use them in our work. They have no place in our life. Just ones and zeros. Aren't they so beautiful? We just live in the matrix, and we don't do emotions here. Now, for some things, that's correct. I want you to imagine this meeting, right? We're designing an API, and I'm like, this function should have 5 parameters. You can't argue with me. I feel that's good. You know, makes me happy, 5. That's emotionally, I love 5. Stop arguing. We're doing it my way. That's terrible. That doesn't mean that any time you use emotions at work, you're wrong. In fact, a lot of times, your emotions are very, very useful for that quick conclusion, for that distillation of your intuition and your experience. I was chatting with Joel just before we got started here. I have to look at a lot of old code these days. There are companies out there that are making their living on code that was written last century. And literally the person who was maintaining it has, if we're lucky, retired. But quite often, I literally get a phone call because somebody died. And if you have an MFC application, how are you going to find someone who knows some MFC? You have to find someone who learned it last century and still remembers it. And when I look through this code, sometimes I go, ooh, at one particular piece of the code. And it's that emotional conclusion that's delivered without data. I'm just flipping through header files, and one of them, yeah. Now, that's not a decision, right? I can't go into a meeting with an invoice, say, please give me $100,000 because, ooh. That would be good, though. But it does give me a signal, and then I go and look more deeply. What exactly is it about this header file that I have a problem with? What have I noticed that reminds me of another situation that went poorly? And then I can have a longer and more detailed conversation after that message was originally delivered. But there are people who will tell me that I shouldn't react emotionally when I see horrible APIs, that I should only ever be logical and fact-based and spreadsheety. And we take it beyond just talking about code to things like getting excited because your team won a game, or because your kid did something amazing, or because something unpleasant happened to you, coming in and being unhappy. As a culture, we tend to police each other's emotions, and there are a significant number of people in our industry who forbid emotions, usually with mocking humor like this, right? So the original Hindenburg was a real blimp. that crashed in the middle of the night and exploded. People burned to death. People fell to their death from very high up in the air. Some people managed to combine the two. It was awful. It was unexpected. It was a dark and rainy night, and it was tragedy. This, on the other hand, is an inflatable blimp that looks silly because it's nose down in a field, right? And we say, oh, is your coffee made wrong? Oh, poor baby. And then like you're not allowed to complain that your day got off to a bad start because somebody made your coffee wrong, or because you spilled something on yourself, or because your train was late. And we suggest that we live in some sort of emotion-free zone, where not only do we not use emotion to make decisions, but we don't express emotions in any of our work-related interactions. But here's the deal. Before I learned Boolean logic, I learned propositional logic, and you maybe did too. The canonical example was that Socrates is a man, all men are mortals, therefore Socrates is mortal, which was borne out because I do believe Socrates has died. Programmers are humans. Humans have emotions. Therefore, see, you don't, no, it's not true. No, but yes, programmers have emotions. It's irresistible, that's logic. We're all pro-logic, so you can't argue. Emotions are not cheating or shortcutting or non-rigorous. They're not for the weak. They are for people. And we are people, and code is made of people. And we are people while we type our code. So, there are books and talks galore on the importance of being able to understand your own emotions as valuable signals where your intuition is delivering conclusions, but on also being able to tell other people's emotions, being able to successfully transmit, for example, I am reassuring and helpful is good. So is being able to successfully notice, wow, that person seems really angry. In our world, we often have to tell people the right way to do something, and then to our astonishment, they say that's not the right way. I'm sorry, did I not just say this was the right way to do this? But no, we have to persuade them, and sometimes not with spreadsheets. Sometimes we have to find other ways to persuade people to do things the way we want them to do them. People, and especially users and management and sales, they come and tell you what they want, and then some nonsense about why it matters, like who really cares? And it's a dumb thing that they want, and you don't listen and you don't care, and then can't understand why there's an adversarial relationship between the users and the programmers. Being able to actually listen to people telling you that a user interface confuses them or slows them down, you won't hear that unless you're someone who can be trusted with that information. You want everyone in your life, your users, your boss, whoever pays you, to think of you as being helpful and valuable. It turns out there's more to that than just being helpful and valuable. You actually have to be able to perform helpful and valuable at people. And when you get into a meeting, we're going to work out what's going to happen. I like to get what I want from meetings. Step one, know what you want from the meeting. I want the deadline delayed. I want the scope changed. I want this feature dropped. I want someone put on the team. But then you will have a number of emotionally things that you have to do in order to get that outcome in the meeting. Explaining to other people what your constraints are, listening to what other people's constraints are, coming up with solutions. We all work in teams of some size or another, and there's always a day when you don't know how to do something. You have to be prepared to be vulnerable, to ask someone, can you help me? I can't do this. And the flip of that is being someone that your team can come to and say, can you help me? I can't do this. And for both of these transactions, there's a huge emotional mediation because people are embarrassed, right? So they need to feel that it's safe and okay to have these conversations and to ask for help and to get help. It's obviously better for the team. And there are days when you have to be brave. There are days when you have to say, I'm not doing that. It's illegal, or it's unethical, or it's not what we agreed on, or something. And these are very hard things to do. They require emotional strength. But all of this is a different talk. It's probably 10 talks. So I just want to talk about the code, because we're all about the code. People say this sort of thing. Wouldn't it be easier to make software if we didn't have these stupid users cluttering up the place with their requests for things? And we kind of laugh, because we do understand that if we didn't have any users, we probably wouldn't have any salary. But at the same time, come on, wouldn't it be easier? You know, without all the emotional baggage that actual humans bring to conversations about software, unlike developers. I just, like, get me out of the meeting, get me away from those people, just get me back into my code, which have no messy feelings in it at all. Right? Some people feel like they can endorse some of this, because code's just logic. Nothing but logic. Nope. It's just not. People tell me there's no emotions in code, but there is. I can see the emotions that you leave behind in your code. I'm going to show you how to see the emotions that people leave behind in their code. And you may or may not thank me for that. I told you I've been reading other people's code for 40 years. And for over 30, it's been C++ code. Not exclusively, but mostly. And I've had that conversation with the ceiling. What? And I started to see some patterns. Certain things in code are there for certain particular reasons. So one of my huge bugaboos for code written this century is commented out code. Like, I will give you a pass if it was 1993 and you didn't have source control. Okay? But if it was yesterday, why are you commenting out the old line of code when we have source control? Something I found in the wild. This is Hungarian notation for those of you who haven't seen it. I've slightly redacted the variable names. This is a system in which there is a current X and a current ABC, and these are kept in globals because this thing is full of global mutable state, but also, for reasons that are lost in the midst of time, in member variables of some object or another. And sometimes they're not the same. Mostly they are, but sometimes they're not the same. And so if the current X inside the object is not the same as the global current X, or for ABC, then there was some special processing required in this system. And sometime, probably 1998, the contents of this if all fell out. They didn't need to do that special processing. But somebody felt like, I don't want to lose this condition. Right? So this is a relatively complicated condition. It's whenever you're like ending and oring not equals and equals is together, you can get it backwards. So they just kept it. Like, if I need this, it's here. And I see that all the time. There's that like timidity or insecurity. I might need it. I can't just throw it away. The other kind of comments that make me crazy are the ones that say things like as per bill and then a date. You know? You can imagine the person who wrote this comment is preparing for a code review in which somebody just chews them out. Just says, what were you thinking? Bill told me to. And so that's what the comment says in advance. Like, don't yell at me. Don't come to me about this. This was totally Bill's idea. My favorite, I did find this in live code that's live now, in production now. Visual C++ 7 was released about the turn of the century. This group apparently adopted it in 2003. And up until 2003, they didn't initialize their variables. But then the incredibly demanding compiler in the form of Visual C++ 7 warned them about uninitialized data. And so our hardworking programmer decides, hey, it's an integer, we can probably initialize that to 0, that should be safe. But then says, oh no, wait, somebody might say, what are you doing? Why did you just suddenly set this thing to 0? It never had a value before. I better leave the old version in with a comment explaining why this is a legitimate move to make. So, you know, someone who's worried that they're going to be called on the carpet for setting an integer to 0 and wants to put it down in writing that, hey, it's not my fault, it's the compiler. I get called in to look through old code. I find something that makes me say, ooh. I find something with a funny name or it's really long and there's not a lot of comments in it. And I start to read it, start to understand it. I'm taking notes. I think I got it. I think I know what it does. Okay, who calls this function? Oh, no one. I just spent, an hour reading a function that is never called. Or that has no side effects and is called once, and the value is put into a variable that's never looked at again, which is equivalent to never called. Why do people do that? Why do they leave that there? You know, they wrote this function, they debugged this function, they got it working, and now they don't call it anymore, but they're not going to delete it. Well, what if I need it? What if I need it back? And again, like we have source control, that's a thing. Better safe than sorry. Let's just leave it there. You can always add code to call at any time that way. Some of that is just in general, they're not cleaning up. They're not going through and putting things in a smarter order. They're not going through and giving things better name. And very often, the number one reason that people don't clean up is because they have deadline pressure. They have time spent pressure. They have average hours per ticket or lines of code per day or something else. And any time that goes back into cleaning up, they feel will be counted against them. When a code base lives long enough, it becomes the lore and the legend that the developers use. There might be some wiki somewhere, but it hasn't been updated since the person who started it left the company. There might be some paper binders on a shelf somewhere full of diagrams. No one looks at them. All there is the code. And the code is the blueprint to how to keep going. So you see this kind of thing. First of all, we don't declare variables all at the top of the function. This is not C. Secondly, wow, variable names. My favorite, the V's, apparently V stands for value. So V1, V2, V3, V4, V5, because I needed 5 values. The line below just completely doesn't even attempt to be representational. It's D for double. When you come into this code and you need a double to represent the spending limit or something, do you say double spending limit? Or do you touch a comma D4 on the end of this line? We care a lot about consistency, but there is such a thing as a foolish inconsistency, right? If most of my variables are single letter D1, D2, and then I have a spending limit and a maximum shipping weight and this, that, and the other with real names that are declared down where they're used, can you imagine some very senior person saying, this is confusing, why are half the variables wrong and half the variables right? And maybe I don't have time to make all the variables right, you know, because I'm afraid I'm going to miss my deadline or whatever, so I just slam another one into the pattern. It takes real bravery to stand up and say, this was okay when there were 2. It was iffy when there were 5. It was clearly wrong when there were 10. And now that there are 20, I'm going to fix it. So when I meet code like this code comes from someone who is afraid. They are being motivated by fear. And fear is one of the most powerful motivators of humans. It makes people do things they know are wrong because their brains cannot outweigh whatever lower lizard brainstem thing is sending the fear signal. Yes, in an ideal world, I'd clean up. But I'm supposed to close 4 tickets a day or I'm going to get fired. There's so much fear, I need another whole slide of fear patterns. People who check things that don't need to be checked. Because I am afraid that I will have been disappointed by whoever wasn't supposed to disappoint me. How many of you have seen this? This doesn't do anything, right? Deleting a null pointer is a no-op. If inside the braces we set it to null as well as deleting it, then maybe this would be okay. Setting aside the whole raw pointer and manual memory management story, there's no need to check. But doing anything to a null pointer is so terrifyingly bad that before you do anything with the pointer, you always check to see if it's null or not, like always. And so their fear is overriding their logical knowledge of the language. And we've all done this. But it also applies to things that you can't count on because they're not part of the language. So why write a function that gets a parameter, and this parameter has to be positive? But it's not an unsigned parameter because, you know, don't start that. So I check, is it positive? And then 10 lines later, I check if it's positive. And then 10 lines after that, don't I check again? Why? Because I can't remember? Or because someone else is giving me this number and I can't trust them, I can't count on them? Yes, it works today, but what if next week they change their code and they pass me a negative number? Now, some of you were thinking, unit tests, right? That's crazy talk. What we need to do is extra ifs at runtime, every time the app runs forever. That's clearly way more efficient than adding testing to your product, right? But people literally don't trust their teammates to remember the rules and to follow the rules and to give them good input. This also motivates a lot of the hand rolling that you see. Why aren't you using the standard library? Do you know how many stories I have been told about the standard library from like 1993? As though nothing has happened to it since. And they had this one particular weird set of data and the sort was slow, or something else was not even necessarily slow, just awkward. And they used the library, they got hurt, and now they won't use libraries. They need to be able to step through it. They need to be able to watch it in the debugger. They can't trust someone else to write code that will work for them because they are afraid. This is interesting to me as a consultant because sometimes people try to solve this sort of behavior with coding standards and with code review and with peer pressure, but you cannot bully someone into not being afraid. You can only reassure someone into not being afraid. So understanding that certain code comes from being afraid is actually actionable information. But it's not the only reason people write bad code. You know, that's the line about happy families are all boring, but unhappy families are all interesting in their own way. That certainly applies to code. Sometimes those tiny little variable names are deliberately obscure. I have had this conversation where I went to someone and said, can you fix up these variable names so they're called things like shipping limit and maximum price? Why? Are you not smart enough to understand this? I'm not going to explain myself to people who aren't smart enough to understand this without having it explained to them. Because if you can't understand it without an explanation, then you probably can't understand the explanation or something. And people give things anti-names. So it's not only not a name, it's not update current prices, but it's like, ha ha, you idiot, you thought there was going to be a name here. I have met beginners who think that you're supposed to call your functions alphabetically, F, G, H. There's a particular pattern in samples and demos where the first function's called fun, because I guess that starts function, and the next one's called gun, and the next one's called hun. And then I've met people who call their functions these because that's what they saw in their samples. It really matters what you call things. And an anti-name, a name that says the name of this doesn't matter, is a total lie. All names matter. We have to give things good names, even in demo code, even on a slide. And calling things F and G encourages the juniors who want to emulate their more experienced seniors to call their functions F and G, and that's never going to help anyone. Specifically on the matter of foo and bar, again, anti-names, they mean nothing, right? They're nonsense syllables. But they come from a kind of a dark humor. They come from a wartime humor where people were being sent out to battles in defective equipment, and everyone involved knew that some of the equipment was defective. Because it's better to send a half-capable, say, ship to a battle than not to send it at all. And sending that half-capable ship may save all the other ships that are going to this battle. And so you'd be on a ship where you knew half your stuff was broken and management knew the stuff was broken and sent you anyway. And from that comes this really dark, dark humor. So we have this snafu, situation normal, all messed up, and its cousin foobar, where things are messed up beyond all recognition. And that's funny, but we're not dying, right? We're making software, we're saving lives, we're changing lives, we're making a lot of money for a lot of people, but we're not worried about whether or not we're actually going to come home from work. And so I decided I didn't want to call on that vein of humor anymore. We got other humor available to us. So I don't use foo and bar, and I don't use F and G. And if it really doesn't matter because it's a completely out of context slide, then I make up something that doesn't matter, like print and update and ship. Okay? Because that way you send the message to the people who are reading your samples and demos, for example, that functions are generally verbs. And that's probably a good thing to send. But this is also another set of emotional positioning that leads to rolling your own. The raw loop, your own container, your own algorithm. I mean, who has met someone who's just learning C++? They got like 2 months experience. They're asking you questions where it's clear they don't really understand the difference between and or, but they're writing their own vector. I've met these people, right? It's like, that's your first job you're going to do, is you're going to write your own container? Every once in a while, there is a particular set of data that the standard library doesn't handle well. Or there is an obscure container type that isn't in the standard library, but that's perfect for your scenario. But that's not most of the cases, right? Most of the cases, this person just believes, well, I'm better than a standard library implementer. Now, I'm lucky enough to have met a whole pile of standard library implementers, and I am not better than them. They are amazing. And they have the time and the effort to find all the edge cases and to make it perfect. I don't want to put that time and effort in if I don't have to. The worst thing this particular person does is the sneering. I don't know if it happens in France as much as it happens in North America, but calling your users losers, right? Come across that? Well, the losers wanted this and the losers wanted the other thing. PEBCAC. Problem exists between chair and keyboard. And not deprecatingly to yourself, but explaining, there's nothing wrong with my software. The user's just an idiot. That's where the problem exists. And of course, RTFM, which needs no translation. Developers who say these things in the developer Slack, they say it in the code. They do this sort of thing too. Let me tell you the story of this function. First of all, it wasn't Steve, and also it didn't say nonsense. It said something much less printable. There was a multi-step business process that had to be done. Some file of XML came from some government server. There was processing. Things got copied, moved around into the processed folder and then into the archive folder. There were bits to be set in the database, rows to be added, you know. And there were endless meetings and flowcharts and whiteboards about all the different orders in which you would do everything. And our two heroes, let's call them Bill and Steve, had a difference of opinion about, let's say, when that flag should be set in the database or when that file should be copied over to archive. And Steve was doing step 4 of the process, and he did a few things that Bill felt were being done too early. So what does Bill do? Step 5.1, he calls undo Steve's nonsense and like clears that flag that Steve just set, deletes that file that Steve just copied, recopies the file that Steve deleted, that kind of thing. Then he does all his processing, and then at the end of step 5, he then does these things when he feels they should be done. Now, that in itself is like adorable, right? Again, we're talking about runtime performance, things being set and then cleared and then set again, added and then removed and then added again because of a team dynamic. But then on top of all of that, you would label your function undo Steve's nonsense just to make it clear as a bell just how you were wasting time and energy because you couldn't agree on a process. And you think, who would do that? People do that. It's right there in the code. It's not just in comments, it's encoded in variable names. You see variables that are called stupid and pointless and that kind of thing, where people are expressing emotionally how they feel about the task that has been set to them. And when I come across an arrogant programmer, that's a very hard thing for me to cope with, because they're sure they're better. They're sure they're better than everyone they have to work with or will ever have to work with. And that's a challenge. But also, this sometimes just comes from anger. Imagine that you spent quite a bit of time coming up with good variable names, long, sensible variable names. But on code review, there was this endless nitpickery, bike-sheddy arguing about your variable names. And they all got changed. Can you imagine when fine, D1. You think you're good at names? You can do the names in the code review. I'm not putting any thought into it. So sometimes this just comes from anger and pain. Sometimes it comes from just being arrogant and thinking you're better than the other people that you have to work with. April Wenzel, she does a lot of stuff about compassionate code. She went on GitHub and she searched some commit messages. Clarification for stupid users. Added UI element to clip posts so idiot users don't whine, duh. It's like a trifecta. Being smarter for the stupid user. These are public. She's not on these projects, right? If April can find them, so can these stupid users who are being talked about. Think about what Agile expects and talks about as relationships between developers and users. Also, these are terrible commit messages in most cases. I'm cool with added UI element to clip post, like if you just stop there, that might actually be a useful commit message. But being smarter for the stupid user, like what have we learned? Or this one down, the last one, be nicer to the stupid user. Dude, try harder. This is how some people are feeling. They're at their desk. They've been asked to move a button or to add a default value or to add an error or whatever. And they think it's wrong and stupid and bad and a waste of their time and they're better than this. They do it anyway and then they leave this in the code so you know how they felt. Steve Miller has a swear engine, he calls it, for malware detection. He says, the way you're feeling while you write malware, you're angry, and your anger is in your code. Those of you who are close enough can see the word he's searching for on line 9. There's a measurable difference in the prevalence of that word in malware and non-malware payloads. So you just look for those 4 letters, and it's a malware signal. Think about that the next time you're calling a variable pointless idiocy. Talk about this kind of a person. Again, someone who's not cleaning up, but their motivation's a little different. They say, why should I spend my time to make things easier for you? Imagine you've got a job that's going to take an hour. You spend an hour and you do it. Now, if you paused at this point and did a little refactoring, spent a second hour, you might be able to get the task down to half an hour every time it needs to be done from now on. But in some companies, here's how that's going to play out. Every couple months, we got to go add a blah, blah type to the whatevers, right? It's supposed to take an hour, but last month, Kate took 2 hours. She must be very bad. And not only that, but we got someone else to do it this month, and they got it done in half an hour. You see how bad she is and how great they are? In that kind of a company, why do I ever invest that hour for my coworker? To make them look better next time? This is often the motivation for the short and opaque names, right? I'm being measured. I have tickets to close. I'm not thinking about the whole team. I'm thinking about me. I'm thinking about making me look good. In fact, sometimes we can draw on that joke about the bear. Say, I don't need to outrun the bear. I just need to outrun you. I don't need to be a really good developer. I just need to be a better developer than you. And if one of the ways I do that is by making you a worse developer, hey, I'm still winning. And you know these people exist. Public variable, that's quick. Then that annoying writing gets and sets. Global mutable state, that's also fantastic. Just, I don't have to change all those function signatures all the way down. I'll just stick a global in at the top. It'll be fantastic. Right, it's quick. I'm being measured. I got to be quick. I got to do what's best for me, not what's necessarily best for the project, for the code, for posterity. And hey, if it means you can't understand it, all the better. I'm the expert and you're not. And my job is safe if nobody knows how to do this. Back in the days of the Commodore 64 and the Commodore PET, yes, last century, very much last century, I knew someone who worked on a team that was making some hardware, and they had custom-made boards with chips on them, and the person who built the boards scraped the number off the chips with a pin. And there's little white writing on the tops of the chip, scraped it off. No one else knows how the boards are made. I have job security. People are doing this in code. People are being selfish. There's this person. You've worked with this person too. It works. Probably, mostly, kinda. We have testers, right? And if we don't have testers, we have users. Like, whatever. I did what I was told to do. It's done-ish. Libraries? Psh, I can't be learning that kind of thing. I got code to write. What? You want to automate? What? A script? Huh? Look, okay, if you care about that newfangled junk, you do it on your time. I'm fine. And of course, the copy-paste edit. And I've gone to people and said, look, this code is the same in these 6 places. It's telling you there's an abstraction. You don't need to do big architecture up front, but it's telling you there's an abstraction. Let's invent an abstraction and all these places can call it. Nah, I'm comfortable with this. I know how to do this. I don't want to learn a new thing. I don't want to think about what to call that abstraction. Nice thing about copying and pasting 20 lines of code is you don't have to give it a name. It's just 20 lines of code. No thinking. Right away you see there's no commitment to the future. You can't argue with this person about how it's going to be easier next time because they don't care about next time. They only barely manage to care about this time. Mostly, this is laziness. There are lazy people, right? We were not all raised to be super hardworking and driven and committed and blah, blah. But I said mostly, because this also can be burnout. If I would get fired for not doing it, I'll do it. Otherwise, I won't. The absolute bare minimum. This may be someone who is literally trying to stay alive. Okay? Sometimes when a company has just driven people too far, you get what looks like laziness. And you know the number one cause of what looks like laziness? Crunch. When you expect people to work 12 hours, 14 hours, 16 hours, to work their weekends, to sleep at work, they produce what looks like laziness. Because each person there is magically selecting what is the minimum I can do. What is the one thing I can skip that gives me a chance to be at home while my child is still awake and actually see my child today? What can I not bother with? And maybe I'll be able to keep my name off that divorce board in the break room. You tell them if you put in an hour now, you'll save a half an hour a week forever. I don't have an hour now, right? If we don't meet this deadline, we're not going to ship this product. If we don't ship this product, we're all going to be laid off, or the company's going to go under. Or if nothing else, I will forever be associated with that failed project. So I can't put any more time in for any reason. Sometimes I see code like this, and I'm expected to believe it was just one person who was habitually lazy and didn't do everything that needed to be done. But then I ask, why was it never fixed? Why, first of all, why wasn't it caught in code review? And second of all, why didn't anyone else ever come into this function later and clean it up? Why is it staying there like that? Sometimes it's the whole team for a short period of time, then the crunch ends, they go back to normal, but again, they don't go back and clean it up. Why not? Sometimes literally it's because they have so many negative emotions associated with that time, they hate to look at that code, it upsets them. So they just kind of put it behind a wall and never look at it again, which is probably good for them, but it's obviously not good for the code base. When you keep a team in perennial crunch, you make horrible code. So you're not just wrecking your people, which is like something worth mentioning, but you're also wrecking your code. So do you believe me? Hands up if you now believe you can see emotions in code. Yeah. I believe you can see fear and arrogance and selfishness and laziness in the code that people leave behind. And knowing that actually changes how I write now and how I read. But I do want to rewind a little bit to the code is logical part, because code is still purely logical in one way. If I run a tool lending library, where people can come and borrow a sander or a power saw, and then bring it back when they're done. and something was due on Monday, and someone comes in Tuesday morning with this sad story about how their dog was hit by a car, so they couldn't come and bring the saw back, I may waive their late fees because I have a connection with them and I feel warm towards them and I want to be nice to them. But if I have a line of code that says, compare the due date to today, if the due date is before today, here's how you do the late processing. That code is not emotional. It doesn't make an emotional decision about whether or not to charge the late fees. That's true. So in that sense, the code is purely logical. But everything else about that code, what variable do you keep due date in? What type is it? Is it like an integer of ticks since the dawn of time, which is January 1st, 1970? Or is it an actual date, time and date? Are they member variables of something? Do you call a function in order to determine whether something's late or not? Do you compare the two dates with a less than operator, or do you call a like before function? All of that is emotional as can be, right? And is sending out a tremendous amount of information to those who can read it there. A disclaimer. I had another shorter version of this talk, and the number one comment I got afterwards was people who came up to tell me a long story about a time when they called a variable X and that was fine. And that's true. Sometimes you call a variable X and that's fine. Sometimes you even have D1, D2, D3 and that's fine. Importantly, I'm describing patterns in code that you see repeatedly throughout the code. Many of the behaviors are actually possibly caused by several different emotions. So you can't just take one line of code and say, aha, you're scared, right? But as you read through the code as a whole, you can develop a sort of a overall feeling. This is someone who's very tentative, who's very unsure, who doesn't feel supported by their tools or their teammates. Or this is someone who's very self-centered and doesn't care about their teammates. And you can gain that information. Secondly, once you have that information, you don't go to the person who you think is responsible and start discussing their emotional state with them. That's not the point at all, right? You don't burst into someone's office and say, wow, I never knew how angry you were. That's not why you want to learn these things. So you look through patterns in your code or your team's code or in other people's code, and you get some insight about what that means, about the minds and the hearts of the people who wrote that code. That then gives you a way to maybe make some changes, not to go talk to someone and accuse them of having emotions, which could probably upset them a great deal. Here's why it matters to me. The number one thing that's changed for me since I gained this insight is the way I feel about the long ago strangers who wrote the code I'm reading. Because I used to be genuinely pretty angry at them. The nicest I got was, oh, the poor things, they can't help it, they didn't have lambdas, right? But there was a lot of like, what? There's no reason. I don't even, And now I kind of get it. There are reasons, right? Maybe you're supposed to close 4 tickets a day. Maybe if this doesn't ship by October 1st, you're going to shut the company down. Like, there are reasons why people wrote that code. And it helps me to be able to know that. But when I come in as a consultant, to be able to tell management, you have a very toxic person on your team. You have a person who's giving variable names as swear words on other people's names and anger and arrogance, and we need to do something about this person on the team. Or maybe you should be changing your processes. Have you heard of this cool thing called source control? There's this concept called automated testing. You should really look into it. And to be able to say to them, the way you run your team makes your app slower. That's an incredibly powerful thing to be able to tell management, because a lot of managers don't see a connection between, well, in some cases, the way they run their team and anything, but certainly not runtime performance. They might say it's taking us longer to write it or it has more bugs, but they wouldn't really believe that it'd be true that there's pointless extra ifs at runtime or setting and then clearing and then setting at runtime because of the way they're running a team. And so to be able to come in and make some changes where you actually have a yardstick to point to and say, this is some things that will get better if you make these changes in your team. And finally, when you want to write code, you don't want to write code that looks lazy or selfish or afraid or arrogant. right? So you want to be able to point yourself to something better. Well, I guess we want to go for neutral code then. Well, I don't think there is such a thing as neutral code, but even if there was, why is that what you would go for? Right? Oh, this code looks really insecure and afraid. Great, let's write code that's confident and capable. Is there something in between that's only a little bit insecure or not very confident? Like, probably not. But even if there was, why is that what I would aim for? Let's be confident. Let's show that we know our stuff. Instead of being hard to understand, thrown together, no design, let's be reassuring and obvious. This is in the right order. Things have the names that make sense. I get it. I can follow it. That's what I want to aim for. I don't want to be an information hoarder like a dragon sitting on a pile of secret formulas guarded by one-letter variable names. I want to be open and transparent. And I don't want to be arrogant. I want to be humble. And finally, I don't want to be selfish. I want to be generous and empathetic. And all of these things, of course, come from strength, right? It's very hard for weak people to be generous. It's very hard for weak people to be reassuring. And so when you take these on as your pattern and your persona, you are showing how strong you are. As mentioned, I'm from Canada. We have winter, real winter. My apologies to those of you who live where there are mountains. And we have to learn how to drive in that, on the snow and the ice. And we teach our children these 6 words. Look where you want to go. You're driving, you put the brakes on, the wheels lock up, the car starts to skid, and you're headed for a tree or another vehicle or a guardrail. And what most of us do is we stare at that like, oh my goodness, I hope I don't hit that tree. And when you do that, you drive right into the tree. And we teach the children to look around for an empty spot where there is no tree or guardrail or vehicle and lock your eyes on the empty spot. And your hands and your feet, even if you've only been driving for 6 months, but certainly if you've been driving for decades, your hands and feet will point the car where your eyes are locked, and you will go into the empty space. Okay, and I've done this. My children have done this. And I can tell you any number of stories about people who were convinced they were going to die, and then they remembered, look where you want to go. They looked, and the car went there. Because just as your intuition and experience gets your emotions to throw up stuff, same with driving, your experience actually just causes your hands and feet to point the car where your eyes are locked. Now that's not a metaphor. That's just like free extra bonus driving lesson. But wouldn't it be a great metaphor? Like doesn't it want to be a metaphor? Isn't it like the best metaphor? If your code is scared and angry and selfish and lazy, let's focus on where we want our code to be, what we want our code to show about ourselves. Clean up. I have source control. Now, I know source control doesn't cover anything, so I'm going to share a best practice of mine, which I call work notes. So if I am doing a new import type on a product, and say we have 10 different kinds of imports, and now we're adding an 11th one. I will make a document, and I will call it Add 11th Import Type. And it starts out with like the specs and the emails and diagrams and photos of some whiteboard meeting and maybe the contents of a sample import file. And as I go along, it's got problems and screenshots of bugs and whatever. And you can read it later as like a diary of the work. And this is the perfect place to paste things you don't need anymore. So I discovered as part of this that we were testing such a thing, but we didn't ever do anything if it was true, so I ripped the if out. And then just keep the if in the work notes. So the advantage of this is it can be very difficult to find in 2 million lines of code that really great if that was somewhere. That's why people don't trust source control alone. But if you remember, I think I took it out when I was adding one of the import types. You can go back through your last 3 or 4 import type notes and search those. As well, it's usually surrounded by words, so I can use a grepper or some other tool to magically find the work notes file that has what I want. So source control alone does not necessarily give me the confidence to just rip crap out and say, I do not need this anymore, but it does give me, I've got my notes here. They'll tell me it. As a result, people who read my code afterwards do not have to puzzle through my commented out unneeded junk. It looks like I totally know what I'm doing. If you do nothing else in this world, always clean up when you're finished with a piece of work. Maybe for yourself, maybe for the next person, but give things better names, put things in a better order, figure out how you can do one test that X is positive and then do all the X is positive stuff rather than every 100 lines or so checking again to see if X is positive or not. And when you're naming things, when you're leaving comments, think of the person who's going to read them as someone who can trust you. You know, at this point, more about this code than you ever will again, or did before. This is your absolute peak when you've just finished writing, say, a function. All the time you were writing it, you kept learning more, learning more, learning more. As soon as you stop, you're going to start forgetting. So you're at your peak. And at this moment, give things the names that explain how they work. Leave comments that explain how they work. You've gathered all this information, and this is the perfect place to record it for posterity. And part of that cleaning up approach is, this should be arranged for, or this should be an algorithm call. Yes, this is how we did it in 1998. That doesn't mean it's how we're going to do it now. I know what's better. More readable for the next person, or faster, or handles more edge cases, or whatever the issue is. I am going to make us do it right. Because I'm in here. Not saying that you necessarily walk up to 2 million lines of code and start replacing for loops, but that if you're in there, that you're prepared to stick up for the right way to do things. Show confidence. You leave behind in the code, wow, whoever wrote this, they really knew their stuff. That's what you want people to think about you when they read your code. That tentative, I don't know, I can't be sure, it might be wrong, I might get in trouble. I think this is the shipping limit, but why don't we just call it R for now? Be the opposite of that. Right? Be this person who gets it. And you can tell as soon as you read the code, this person gets it. Libraries. Libraries are your friend. You don't have to go home. Well, you're here this weekend, so you can't go home this weekend. You don't have to go home next weekend and write a JSON parser. And we all know someone who wrote a JSON parser over the weekend and how that worked out. A tip, when I include a header from a library that's not the standard library, say the JSON parser, on the same line as the include, I put a comment with a link to the documentation. Now for the rest of time, because we are copy and pasters, it is usually only one character to copy and paste the whole line rather than selecting just the include part, right? So someone's going to copy and paste the whole line, and they're going to be pasting that documentation link every time they do. And it's a really easy way to make sure that people understand where you got your JSON parser from, or what have you. Comments should be nice. Comments should, yes, show that you know your stuff and you understand this, but they should also show that you are confident that the person reading this knows their stuff and will be able to understand what you are saying. So you don't assume that suddenly your code is all going to be maintained by 4-year-olds, right? It's going to be maintained by good, smart people who mean well, and you can leave them comments. So this is an interesting comment because you could argue that the code is terrible because it's magic numbers, and maybe we should have made a bunch of const expert things that represented these numbers. But at least the comment, I think, is worth talking about. In the US, which is where this software is from, the standard piece of paper size is 8.5 by 11. And this is a Windows application that is not a WPF application, but that has some WPF parts. So everyone who's reading this code knows what WPF is. So Microsoft's managed C#y Windowsy thing, and knows what DPI is dots per inch. And so whatever page is, it likes its height and width to be in dots, so we'll do 8.5 times 96 and 11 times 96. Now it is actually intriguing because this is landscape rather than portrait. So we say 8.5 by 11, but it's actually being set to 11 by 8.5. So that presented a challenge about consistency. Should you always set the width and then the height, or the height and then the width? Or should you keep them in the order that they are in the comment? In the end, we decided to keep them in the order they are in the comment. So we say 8.5 by 11. So first we use the 8.5 and then we use the 11. And that's the kind of thinking I'm talking about, where you're not just stuffing WPF 96 DPI in a comment and moving on, but actually thinking about the next person and how they would interpret what you were to write in the comment. Names, names, names. You have no better place to help than in the name of a variable, the name of a function, the name of a class, the name of an instance. And when you just decide to have I and X and R1, you are throwing away a place to tell people what's happening. So, helpful names. You want your code to try to say, hey, next person, whoever you are, I know you're as good as me. I'm going to explain this to you. You're worth explaining to, and I know you will understand my explanation. We've all seen code that says the opposite of that. You can figure out how to write code that says this better thing. You can write humble code. Now, the disclaimer that I always give, humility is like Zen. If you think you have it, you don't. People who say, oh, I'm very humble. I'm better than everyone on my team, but you won't find me saying that. Still, you can try for it. You can try for your code to be humble, even when you have to say, look, it's hard to be humble when you're as great as I am. You know those moments where you come across some code where somebody clearly was thinking, right? You go, oh, this is nice. Look at this. You know, someone who really understands what encapsulation is for and has encapsulated things that belong together and is not exposing things that are for internal use only. We talk all the time about achieving an appropriate level of abstraction. It's kind of like art. You know, I may not be able to define it, but I know it when I see it. We've all seen things that are over-abstracted, architecture astronaut, add another level of indirection, it'll be fine. And we've all seen things that are under-abstracted, copy-paste, maybe edit if you're lucky. So when you come across something where clearly thought was put in, maybe this is not the first iteration of this code by any means, but now look at it. I love this object, it's just what we need for this purpose. That's a joy to come across. Refactoring, rearranging, renaming. I think rearranging is promoted. Doing things in a logical order, doing things that belong together rather than one of them here and one of them down there. Keeping things physically near each other in the file if they're related to each other. Save me from people who have functions in a CPP file in alphabetical order. Whether it's rearranging the code flow or rearranging the order of the header layout or rearranging the way the functions are in the file. Again, you will never have more knowledge about this file than you do today when you think you're done. So that's when you take that time and you rearrange it. And yeah, give things better names, maybe break out that 5,000 line function into some smaller ones, what have you. You know, you read some code and you go, this is brilliant. I love it. It's not because it's obscure with some strange thing with a bit shift and a twiddle and I noticed that if you throw away the sign bit, this is what happens. But more that it's brilliantly, obviously correct, that you just get it. This is real code in another language. In this language, their switches can do rangy things. Okay? And I was given this code in real life. Anyone know what it does? I'll read it. It's got something called an application that's got properties, one of which is credit score. We're putting that in a local variable to switch on it. I don't know why, but we are. And then we have three cases. We have the case when n is less than or equal to 50. We have the case when n is greater than 50. And we have a default in case there are any integers that fall outside those two possibilities. Two of these three cases return false. One of them returns true. It takes a little while to read that. It's not wrong. It's not even slow, but it's long when you could do this. This is the sort of thing I'm talking about being obviously right. The other problem with this code is you can have some really fun bugs if you change 50 in only one of the two lines. right? Here, there's only one place for the magic number. It is perhaps marginally better to have a magic number now than it was before. So there are things you can do that just hit that brilliant button. You know, yes, maybe you're making it shorter, maybe you're changing a variable name, but more importantly, you get it so that as soon as someone reads the line of code, you pass if your score is over 50. Got it. Dramatically easy to grasp is an underrated ability. You probably can't do it on purpose, but you can notice every time you do it. You can go, oh, that is better. Yes, okay. And give yourself that moment of positive reinforcement so that you will do it again next time. Also, this is where I see people who share information, the opposite of scratching the numbers off the chips. Say, my job is safe if any and all of you can also do this with me. Also, I may be free to move on to a more interesting part of the job, rather than being stuck forever as being the person who maintains the MFC app because nobody else knows any MFC. Showing generosity in your code is something that is incredibly rewarding. First of all, it's fun, right? You know when you are doing it that you are giving a gift to the future, whether it's you or whether it's someone else. And just as it's fun to give presents at Christmas and watch other people open them, it is fun to be generous in your code. But it also brings incredible rewards. It brings rewards to the team because people who always get what they need and who always feel supported do amazing things. And every once in a while, it's you. You know, like one spring, I was walking on my property and there were spring bulbs flowering. And I was just like, oh, that's so nice. And I had this surge of gratitude. And then I realized it was me who had planted them the previous fall. Oh yeah, that's nice. So sometimes your generosity lands on yourself, and that's a good thing too. Oh, C++. Naming is hard, yet we will not go shopping. We are so famously bad at naming things like RAII, which, as I'm sure you all know, stands for Scope-Bound Lifetime Management. None of us are good namers just because we got born that way. You have to learn how to name well. And you know why it's so hard to do it? Because it requires empathy. And we don't particularly value empathy as a skill. But you have to put yourself in the shoes of the person who's going to consume this name. What information will they bring? What will they be thinking like when they decide whether or not to use your name? So if you have a 5,000-line function and you refactor that function into little 100-line this and 100-line that, you know what they do. You're right in there. This part updates the inventory, this part calculates the shipping cost, and then this part confirms that that's going to be okay, and then this part does the payment transaction. And you can name those things like you just did, right? They're easy to name. But then you get a little more separation so that you're not the one who's consuming the name. Maybe you're designing a class and it has some public functions that are going to be called by the people on the other team. Now it's harder. We have this famous empty function in the standard library, which answers yes or no, is something empty, but people believe empty's a thing. Not so easy all of a sudden to name things. And then if your API is not just another team in your company, but maybe it's like some web-based thing that you're implementing, now strangers are calling your API. And maybe you call your customers customers, but they call them guests. Maybe you call the people who take exams students, but they call them candidates. And so you don't even have a common vocabulary anymore to build the names out of. And as we continue to increase the distance between the people who are coming up with the names and the people who are consuming the names, we get this bigger and bigger kind of empathy gap where the people who are producing the names can't put themselves in the shoes of the people who are using them. And I have a story that I like to tell for this one. And this started as a real story that I told a non-C++ technical person who pointed to something and asked where it came from and what it was for. And so I told this story. In the standard library, we have the algorithm header, and I love the algorithm header. I think, Probably only Sean Parent loves the algorithm header more than me, and we could probably fight over it. I have never yet said this is obviously a rotate, but I have said this is obviously an any of, so that's close enough. And in the algorithm header, we have sort. Sort is a good function. You give it, ignore ranges for the moment, you give it some iterators, usually begin and end of a collection, but doesn't have to be. And you don't even necessarily have to give it anything else. It'll sort that collection. So by default, putting things that are less than at the beginning. So if I have 100 integers and they're all 1 through 100, but they're jumbled up and I sort them, then there'll be 1, 2, 3, 4 when I'm done. But you don't have to use that overload. There's a predicate taking overload where you can pass in, here's how to sort employees. So I can sort all my employees by their last name or by their salary or by how much sales they were responsible for last month. Excellent. Now, we're C++ people. We care about performance. So I have a vector of employees, solid objects, not pointers. And I want to sort my 1,000 employees according to who made the most sales last quarter. Sort is going to copy those employees around a lot, right? That's what it does. Standard Library in general is a big copy fan. And if I want to sort my 1,000 employees by, did I say commission? Let's go with commission. I don't really care who was 500th and who was 501th, right? Who was 900 and 901th and 902th. I maybe care about 10 high performers. The rest of them, whatever. You weren't the best. So we have partial sort. Yay! That's fantastic. When partial sort is finished, again, if we went with integers, and I said I cared about 5, I could have 1, 2, 3, 4, 5, and then all I know about the other 995 or whatever is that they are all larger than 5. That they're in any order. They're not the order necessarily that they used to be, but they are larger than those ones that I sorted to the front. So for my employees, I could get my 5 best performers with the highest commissions up to the front, and the other 995, all you know about them is that they are not as good performers as those. Okay, that's better. Now I'm not paying to sort the whole collection. But imagine that, I don't know why I have a vector of 1,000 employees, but bear with me. It was sorted by last name. And when I do this partial sort on it to get the high performers to the front of the array so I can do something with them, then I need to resort it back by last name for the next thing because I've permuted it. That seems like it would kind of be wasteful. Well, I could take a copy, and then I could partial sort the copy, but I'm paying to copy 1,000 elements over and partial sort them, so we have partial sort copy. When you're done with partial sort copy, you have a small little vector of, say, 5, which is your best performers, the things that would have been at the front of a partial sort. And the original vector is unpermuted and unchanged. And you can carry on and use that how you want to use it. That's great. Did you already all know about partial sort copy? It's a useful little function. But it's a terrible, terrible name. It is an implementer's name. You think the name makes sense right now because I told you the story in this order. But if you just went to CPP reference, you would not find it. Because, I think it should be called top N. Because that's what it gives you, right? Give me my top 5 performers. Or my top 3 customers or whatever. That's a name that speaks to the consumer and says what you will get if you use this function. Partial sort copy is a name that speaks to an implementer and says how we made it and why. And that's logical, and it makes sense if you tell the story like this, and this is, in fact, how I now always tell the story of partial sort copy. But it is a terrible actual name, right? Top N would be probably a better name. Although someone argued with me, said, you can't tell from top N whether it would be sorted or not. Okay, well, maybe we'll try to figure out how to solve that. But it's a great algorithm with a bad name because we're bad at naming. One of the reasons we're bad at naming is that distance between the namer and the consumer. Jessica Kerr is the target of this tweet from Travis Simon. He tells her, just renaming my variables, not something a user would see, the variable in the code, from error message to help message, made those messages better. How many of you would have thought that could be true? More hands than I expected, about a quarter of the room. I did not think that would matter at all. You're not talking to the users differently. You're talking to each other about the users differently. And it made a difference. So skeptical, sure, but maybe try it. Maybe find something in your system that has a name that could be a little bit more friendly or gentle, and see if changing it means. Because error message says, I'm going to tell you what you did wrong and why you are stupid and dumb and bad and should stop using our product. And help message says, I'm going to tell you what you need to know to use this product correctly. And in enterprise systems, there are all kinds of buttons you're not supposed to click. You know, and the stupid users with their problem between the chair and the keyboard, click them. And a help message says, look, I'm sorry, but if you click this button now, it won't work. You have to wait until you've done this other thing. Whereas an error message says, what kind of a person would click this button? And it actually shows up in the words you choose to use when you explain to them why they have to do it. This one really hit home to me. This is Bridget Cromhout, again on empathy. They're talking about documentation, but I think it also applies to comments and to what we say in meetings and to emails. When I was a small child, both my parents are physicists, both my parents have PhDs in physics, and I would have trouble with my science homework. And they would literally say, I don't know why you're struggling with this, any fool can do this. And they couldn't figure out why that was not working for me. See the thing about empathy and scientists and geeky people in general. When you say that it's easy, just, clearly, simply, obviously, merely, you think you're being reassuring. Like, don't be scared. This is easy. Anyone can do it. And that's fine until the moment the person can't do it. Because they think to themselves, I suck. Because it's just, and it's clearly, and it's simply, and it's easily, and it's obviously, and it's merely, and yet I can't. So, I have actually banned the word just in my house and in my office. People say, you can just rename the, stop right there. There's no just. There is no just. If you want to use these kinds of reassuring words at the beginning, that's fine. I'm going to show you the 3-step process for this. It's quite simple and clear. But then stop saying that it's clear and obvious and simply and merely while you're doing it, because anyone who's not following is feeling rejected as they don't follow. So back to we're talking about gentle comments and helpful comments. Think about this phrasing in your comments and try to imagine what would happen if someone isn't understanding your simple stuff. But we were talking about good things you could do in your code. There's a little side range on naming and empathy. Here's something that really gladdens this old heart of mine. Code that actually does what it's supposed to do. It compiles, it links, it runs, and the tests all pass. But I mean really. Not it compiles with 73 warnings. Especially, it compiles with 73 warnings, and if there's ever 74 warnings, we have to have an all-hands meeting, right? It just compiles, no warnings. It runs, and I mean it really just runs. You all know these apps. Oh, you get an exception when you first run it, but you can just hit continue, it's fine. Doesn't mean anything, it's fine. Or most of the time, maybe all the time, but certainly most of the time, when it runs, it leaves a file behind in long path here. And you have got to delete that, because if you run it again without deleting that, it blows up hard. In fact, it can corrupt the database, so be really careful. It's like, why is that okay? Why does that count as it runs, right? So when I meet code that doesn't do any of that stuff, that just works and compiles and links and runs, I'm so happy. And there's tests, and I don't mean 7. You know, there's tests, there's a full suite, and I can read the tests to understand what the app does. Oh, this is nice. This is clearly written by someone who knows what's right and has done what's right without having to be poked and prodded for every single step of it. When you're reading code that's got a 30-year pedigree, it isn't all modern, but you come across bits that are. Maybe using a library, maybe a lambda or a ranged for somewhere where it's obvious and appropriate, maybe some tooling from this century, or heaven forbid, from this decade. Not tools for the sake of tools, chasing the latest butterfly, ooh, another build system, cool, let's all switch over. But I can actually see a benefit in the code from the person having adopted a newer practice. I see that, I want you to know when you write that, I see you, and it's good. And not just copy, paste, maybe edit a little, but actual modern practices, whether that's pair programming, code review, automated testing, whatever, as I say, things from this century that you're using to produce better code than just, oh, I remember we had something very similar and this other thing over here, I'll just copy it all over and I'll change SQL to Oracle everywhere, it'll be fine. When I see code like this, I see a commitment to the future, whether that's for yourself or for someone else. It's worth making this easier next time. It's worth taking away that stray uncaught exception that doesn't matter. It's worth taking away that warning for next time. And that hard-working code is, I think, the best legacy that we can all leave behind. When you read code like this, you know something about the person who did it. And again, here, when I say code, I'm not just talking about C++ source files, right? Now this is about your tests, this is about your build systems, about your project system, all of that. You know, you can choose what emotions you put in your code. When you do, when you decide, my code's going to be generous, my code's going to be empathetic, my code's going to be humble and hardworking, obviously, that makes your code easier to read. That was the point. That was what the hard work was for. That was what the generosity was giving the gift of. So if you put in the work to make your code easier to read, surprise, your code will be easier to read. That means that since you're the one who probably reads it the most right away, the immediate beneficiary will be you. I come back to things after 6 months away, or a year away, or 5 years away, and I don't remember anything about how they work at all, right? But if I'm lucky, oh, all these variable names make sense instead of being D1, D2, D3. Or this huge, I remember I split this huge thing up into small things that had names, and now I remember what the pieces are, and I can find the thing I need to change. Or, oh, I set up some abstraction, so I only need to make this change in one place instead of in 7 places. You will have a happier time maintaining code that has got these positive emotions in it. That's the point of them. It's not a happy, weird side effect that happens to occur. It's actually why you're doing it. You're trying to make code that's enjoyable to read and easier to maintain. And the number one beneficiary of that is likely to be your own self. But when it isn't your own self, when it's someone else, they probably know it was you. Especially if your code is very different from the older code. They'll be like, oh, I'm in a Kate section. It's going to be a good week. And that's going to happen within your team or even after you've left the company of how people think about you if they were ever to, say, be asked for a reference later. You're going to improve your own reputation, even if you're not technically improving the code. Right? So some of what I've shown you is like stop testing things that don't need to be tested. That's going to improve your code. You're going to be faster at runtime. Some of it's going to make your code shorter. There are a whole pile of things that are genuinely going to measurably improve the code. But I just wanted to also point out, it doesn't have to. That's not a requirement. Like, even if the code isn't technically better, you're going to enjoy it more. Other people are going to enjoy it more. And that has a value. Because enjoying your job is okay. It's not like you have to be miserable all the time at work. That's why they give you money. That's not how it works. You can actually have a wonderful time and ensure that the people after you have a better time. And that's not cheating or bad. Like, wow, I'm getting paid and having fun. Perhaps I should give the money back. No. Do that. Get paid and have fun. And do the same for the people around you. So here's what I want you to start doing. Number 1, care. Bring your caring self to work and care, which is hard because work can hurt you. So it's easy to kind of build a wall, and be detached and be ironic and all of that. But care about that 10 years ago person who wanted to go home so they could see their kid go to sleep. And so they didn't do everything that needed to be done in this function. And care about the people who are going to maintain the code that you're writing. When you bring your whole self and start caring, things will get better in the code immediately. Show your stuff. You're good developers. You know what you're doing. You know what's in that variable. You know what that function does. Why do you go home without leaving that information in the code? Strut a little. Give things names that show your powers, not some obscure weirdness or some tentative thing like, I don't know, I'm pretty sure it's a percentage of some kind, so I guess I'll call it PCT3. Like, come on, you know what this does. Show what this does. Whenever you can, be generous. As I mentioned before, this is the thing that brings you the biggest rewards. It's to be generous to future you, and to be generous to your teammates, and to be generous to your users. And work on being empathetic. Understanding, if you think it's a ridiculous request to change the color of a button, find out why they want to change the color of the button. Then you can be more understanding and support their desire, instead of writing a commit message about change the color of the button for the stupid, whiny users. Like, how's that helping anyone, right? When you start caring about them, you will actually write better code. Right? Your code will start to be faster when you start to do these things, because there are a lot of anti-patterns wrapped up in being angry, being unappreciated, thinking this is a dumb thing to do anyway, and so on. Think about those malware authors who are filling their executables with swear words as they write. You are going to put emotions in the code you write, because you are a human being who feels emotions. And some of them have got nothing to do with work, right? Sometimes your cat is sick. Sometimes your life partner is sick. And you're not going to turn that off when you go to work. But a lot of those emotions come from work. People are pressuring you to do things at a pace that won't let you do it right. People are pressuring you to do things that you know are not right, maybe technically right. And people are threatening you with maybe, we'll shut this group down, we'll fire you, blah, blah, if you don't. And that doesn't make good code. But when you know that, then you can say, I'm going to choose what emotions my code shows. And you can choose to show positive emotions in your code. And the benefits to you and to everyone else are going to be very spectacular. So I encourage you to look at code with new eyes. More importantly, to type code with new hands that are connected to your heart too. Thank you. I believe there are mics, and I would love questions.
Don't you think that the central point of emotion, about emotion in code, is about the social characteristics of writing code? I think it's broadly misunderstood because we don't see writing code as a social activity.
That's correct. We think of our alone in a dark room, writing my code with no interaction with anyone, not my coworkers, not the people who are going to use it. But the truth is, it's very social. Yes.
Yes. Moreover, when I would make an analogy with learning language in as a child. When you can't express your feelings, you're angry, you have bad emotions about that.
Well, that's interesting. I think that's a really valid point. So if you're unable to express an emotion, it sort of bubbles out as anger, and that same thing may happen in code, that you maybe have a number of different emotions you could be expressing, but the only one that manages to get to the keyboard is your anger.
Okay.
That's interesting. Thank you.
It's a point. Don't you think that software engineering as a language, solid principle, dependency injection, functional programming, design pattern in the world?
Sure.
It's a language.
It's like so you're learning a language to express
your feelings in code.
Yes, I think that's valid. And I think then that by being more fluent in it, we can choose what we're going to show in it. Yes. Thank you.
Hello. First, thank you very much for coming here and sharing your experience and your vision through this lens, which is very interesting. I'm getting older now. I'm focusing more and more on these aspects, much less on the micro details of what's the new shiny features, and realizing how important the team culture is and the great impact it has on the code. And I try to develop that. And I'm facing some difficulties, and I would like to know how you would address that. For example, soon, next month, I will go in a team for 10 days maximum to help them to find something. So often the question is, we are facing technical difficulties, and now I know behind technical challenges, at least 90% of the time, there's a problem with the teams and the people and how they work together. And I have only 10 days to try to make them realize or identify unsaid things or all these emotions that are here, that kept. And sometimes people, the biggest thing for me, because I've been in such situation, is where people are heavily demotivated. It's something is broken. And I've been in this situation, and it's very hard to give hope. So how do you address such a situation?
So I have an advantage, and it sounds like you may too, in that you're coming in as an outsider. When you come in as an outsider, you are disruptive. That's kind of the point. And often as an outsider, I can say something that an insider has already said 10 times. But suddenly, partly because of my bill rate, management decides that it might be a brilliant idea. And the person says, I said that 10 times. Like, I know, that's cool. Got anything else I should say for you that you want to have happen? Because it's going to happen. So just being an outsider can help. But also you can kind of shortcut the process. You only have 10 days. Rather than spending 9 days to find out that they're very resentful and they don't like crunch and whatever, you can maybe see the evidence of that on day one. And you can say, tell me what was happening in the team when this function was written. Aha. How often does that happen? You know, what do you think if we avoided that happening again, your code would get better? And you can sort of compress some timelines because you get these quick signals. The earlier versions of this talk, things like selfishness and laziness and arrogance, which are bad things, that I saw that was the only explanation for certain behaviors. And then I came to realize, like, no, a person can be burned out. A person can be very angry and, as you say, demotivated because they were never listened to before, so now they can't be bothered. And that's a subtle nuance to pick up. Is this person just an arrogant jerk, or are they someone who has been rejected multiple times and has now built up a shell to prevent further rejections? To the extent that you can quickly get there, you can have very dramatic breakthroughs. It may involve crying at the office, be warned. Really, seriously. But when you understand the reason someone's doing something so counterproductive is because of the environment they're in, and nobody meant to put them in that environment, and you fix it, that is amazing, and it does happen. Yeah.
I remember, the main thing I will remember is show your confidence. So be confident in it's right to do it that way. I already do the way you do. I would start with just 2 days, because usually what I realize is we already know what we should do to improve our code.
That's
so just ask the people what we should do to improve our code, and there is many comments, and most of them are legitimate. So then the question is, why don't we do it?
Right, so you have this big meeting that says, don't leave commented out code behind anymore. We have source control, but everyone keeps leaving their commented out code behind. Having another meeting that says, hey, everyone, we have source control, it's not going to fix it, right? But then if you understand the reason that they're leaving the commented out code behind is that they are constantly being jerked around. You know that one user who makes you make it blue, and then the next week it needs to be red, and then it needs to be blue again? And so you're like, well, just leave the old stuff there because they're going to have a brilliant idea next week to change it back. So, no amount of telling people not to leave commented out code is going to fix that. You need to fix the people who are kind of jerking the developers around and give them a more consistent life experience. Or teach your developers, like, hey, life changes. And yep, it went blue, red, blue again, and that's life, and maybe someday it'll be red again, and don't be bitter. Just make it how it needs to be today, But you can't do that while you're stuck in, like, bullying people into not being afraid. That kind of thing is not going to happen. And endless meetings about, hey, it turns out we have source control. That's not going to make people change their ways. You have to know why they're doing it. Yeah.
Yet again, thank you.
No, you're very welcome. Here.
It's not really a question, it's more like a comment. You spoke a lot about emotions in writing code, but I think another point where emotions are very important is emotion doing code reviews and being kind to the people you're reviewing,
Yes.
and being humble in doing the code review and helping them and helping yourself to understand why the code was written that way. And I think that now that most people do code reviews, I still see people doing some code reviews with the mindset of, I'm going to find your faults. And
Yes, yes,
yeah.
absolutely. I mean, being generous and humble in a code review is really hard. Our natural position is, well, I'm clearly the best. That's why they chose me to review your code, because of my being better than you. And I'm going to find stuff in it that's bad because that'll prove that I really am better than you. And if all I say is like, wow, you worked really hard, this is fantastic, like that's a wonderful contribution to a code review, but a lot of people feel like it isn't because like, oh, I have no comments, right? So one of the things that I do when I have no comments is I never say I have no comments. I say, this code shows like really great encapsulation, or I like this version of the function so much better than the old one. Like that takes no more time than I have no comments, really, you know? But I think you're right. It's probably another whole talk, how not to be a mean code reviewer and how not to make people afraid of code review. But I do see a lot of, there used to be bad code because no one was reviewing it, and now there's bad code because people are writing defensively against the mean code reviewer. And that's that same fear, right? So if you find out, oh, people are doing that because they're afraid of what will happen in code review, then stop yelling at them not to do that. Fix code review, and they'll stop doing that. And that's the big insight for me. If you're afraid of something, I can't yell at you to don't be afraid. I got to go fix what you're afraid of, make that better. Yeah, thank you. That's an excellent point. At the very back.
Good morning. I just would like to express an emotion of because I'm grateful, and it was the first time I see a person speaking about emotion in code, and it makes me very happy. And my emotion is happiness. And,
oh, thank you. You're doing the same for me. It is true. I've never heard anyone talk about this, and I've just started talking about it, and it's like a floodgate opens up. Everybody wants to tell me a story. And I hope it's something that continues to spread and that everyone keeps talking about this stuff, because we too often think that we aren't emotional when we're coding, and we are. So we might as well admit it and have it be great. Yeah. This question here. I'm just checking the time. I would talk to you guys all day, and we are still good. We can keep talking. You guys, you people, all of you. Sorry, I'm trying.
Thank you, Kate, for this very interesting presentation. I found it particularly interesting that you just said sometimes you don't have to fix that particular person, but the code reviewer. And it made me think, do you have like a shorter version of this presentation that aims management, how to fix the negative environment? Something that we could reuse.
So absolutely. Most of what I see, I've come to realize, most of the bad code that I see is caused by bad management. Like people wasting runtime cycles on checking something that could have been established with a unit test or by using an unsigned parameter or various things, because the way the team is constructed, the way the team is measured, the way the team is rewarded is causing counterproductive behaviors. There probably isn't a generic version because every management needs to hear specific examples to them. But this is something where I'll come in, and as part of trying to modernize people and modernize code, other things get revealed. And then you start saying, you realize this is happening because something that's really not about the programmers, but about the way they're managed. Sometimes that doesn't take on the first delivery. Management doesn't always want to hear that. But there is so much bad code that's really caused by the team dynamics or project dynamics, and especially schedule dynamics. Yes. So understanding that gives you a place to stand when you want to stand up for something. When you want to say, actually, we cannot do that by March 1st. Not well, and not in a way that we can really fix up in April either. So let's have a reasonable deadline and do this better. Yeah.
Thank you.
So first of all, thank you for coming again. I've seen you give this talk on YouTube, and I've been struggling with one thing that I still can't get my head around. So I'm a team lead, and I have this developer on the team who was there before I arrived, and you could say he's kind of lazy because he's not trying to update his skills or try to get on with best practices. And I'm trying to be empathetic about this, but it's very hard to push him. So
Yes.
how do you make him understand this?
So this is definitely something that happens where there's 5, 11, some number of developers, and then there's, let's say, Steve, right? And Steve has his own office, maybe. Steve doesn't have to come to the meetings, whatever. He's got a bunch of special exceptions. And Steve doesn't have to write unit tests because he thinks they're dumb. And he produces so much other good stuff that we're gonna do it, right? So this is a very hard thing to do as an insider, but it's easy to do as an outsider, which is this myth of, oh, but he's a really high contributor in other areas is a very, very poisonous myth. I mean, this is in some companies why you have, for example, harassers, right? Oh yeah, but boy, he sells so much stuff. We make a lot of money, so it's okay if we go through receptionists kind of fast because they don't like getting hit on or whatever. And it's not okay. Like, it's not okay at the very core of the company. And I think the same is true of if the team has adopted a particular set of practices, code review, tests, pair programming, egoless programming where we're all just picking tickets from a pile, whatever we've adopted, to have one person who says, I don't do that, can be really poisonous. And so at some point, gently but firmly, they need to be told, this is a condition of employment. Like, if you want to be on this team, you have to be on this team. And if you care that much about it, then that's going to be the condition. And then they can decide, okay, I like being on this team. I guess I can adopt this. Or, well, then I'll go find a team that likes me for who I am. That also can work well for everyone.
Right. So what if this is not Steve being a jerk just because he wants to be a jerk, but he's just, not getting it, like,
well,
kind of
it.
incompetent?
That's right.
More.
It's not usually because they're a jerk, right? It's usually because they are afraid. Look, there's a joke going around my age group about the man who retired because he didn't want to learn Git. And I'm right there, like, so far I'm managing to both not retire and not learn Git, and that's working for me. But, like, it's hard. You have a way of working, and then people are like, oh, but we do this new cool thing now. And this new cool thing doesn't even do half the things the one I know does. Maybe it's a flash in the pan, it's going to be like a JavaScript framework of the week. So if they're afraid of looking silly, right? I'm the most senior developer in this whole company. I have 30 years experience, and I can't remember how to do the thing that the person with 1 week experience knows how to do. So then how can I construct an environment in which they won't be afraid of looking silly and they won't feel embarrassed or ashamed, and everybody can count on everybody else? That's way harder than saying, I'll fire you if you don't do it, but it's obviously way more rewarding if you can, right? So if you can get to a place of trust where they can tell you why they're not doing it, or you can intuit why they're not doing it, and then you can fix it. So do you need some training? Do you need to be paired up with someone? Do you need a face-saving pair up where we say, I'm going to pair you up with this 1 week new graduate so that you can teach them our idioms and our programming style, but at the same time, the new graduate's going to be teaching you Git or teaching you testing or whatever it is that you refuse to do. And we'll say, you just watch the new grad type that stuff. Hopefully it'll rub off on the senior. So there are various like tricks or techniques, but what it comes down to is you have to find out where the resistance is coming from and not assume he's just lazy, he's just a jerk. That could be the answer, it sometimes is, but if you can find out where it's coming from, then you can do something about it. Yeah. Or, like, there is still the option, there is more than one company in the world. So, right, that can work for everyone. This side.
Hi, Kate. Thank you very much for the talk. It was really nice, especially as an opening talk. So you showed us, I think it was a sort of praise of self-awareness, social awareness, and emotional awareness. And actually, I think most of it doesn't have to do with coding. And you illustrated this in a very obvious and cool way, which is somehow bad feelings leads to bad code. And if you get good feelings, you get good code. But I'm sure it's not that hard line, let's say. Can you elaborate a bit on the fact that it's not actually that
No, because,
black and
for
white,
example,
I guess?
I can come to work very, very happy that my team won, I'm not going to magically write better code. I can come to work very sad that my cat is ill, I'm not going to magically write bad code. But especially when those emotions are specifically aimed at the code, the users, the team, and yourself, that's when they manifest in the code. So if I'm afraid I'm going to be fired, if I'm angry at the stupid user, if I'm angry at my teammate who insists on setting that flag 3 steps earlier than it obviously should be set, that's what spills out into the code. And if I think of future me or future person next to me warmly and with care and love, then I will write for that. If I think that what I have learned in fixing this function is worth learning, then I will want to record it. If I think everything I've done to this function is just ridiculous and should never have been asked for and wasn't worth my time, then of course I'm not going to invest any time in giving the variables good names, right? So it's where those emotions are pointed. And I think all of us have had days, weeks, months of doing stuff we think is ridiculously a bad idea, should never be done. I just recently went through a situation where somebody wanted to rename A to B, but they said, no, we don't really want to do that. What we want to do is want to add B and then write a whole pile of special cases that make it work exactly like A, and then we'll take A away. And like renaming A to B would have taken 5 minutes, and we spent like months because of two particular things that wouldn't be solved with a rename, and then just before we went live, it turned out those didn't apply. So there was a lot of anger in that code. Because when you know your time is being wasted, you're angry, right? So in order to get the full benefit of this, part of what you have to do is have a more functional team beyond the developers, to the stakeholders, to the people who tell you to rename A to B or what have you. And if you feel your time is valued, you will use your time more valuably. If you feel your time is being wasted, you won't. So knowing that means that you can't just put people in a room and yell at them, and then they'll be generous and empathetic. Like, that's not how that works at all, right? So it's not enough to say, well, you have a foosball table, so you must be happy, so I'm sure you're writing good code. Definitely not. Back here.
Hi, Kate. Thank you for the great talk. I have a question about basically when people or developer write bad code, it's called sometimes technical debt. Is there any mean to measure that technical debt? So basically it's could be reported in some sort of dollars or currency or wasted time to management. So basically they could
That's
be
very
aware.
difficult, right? So one measure of the cost of technical debt would be the time it would take to fix it, right? But management can reject that because they'll say, well, it doesn't need to be fixed. So that's, for example, like a first-class plane ticket costs a lot of money, but I don't care because I wouldn't spend it, right? So an upgrade is worth only a fraction to me of what a first-class ticket is because I'm never going to buy a first-class ticket, and management is never going to let you rewrite the whole thing the way you want it. So the real cost of the debt is the friction that it imposes. So if you have the 5,000-line function, every time we want to make a change, it takes 2 hours longer because the developers have to reorient themselves in this mess, and sometimes their change breaks something 5,000 lines further down. And if we would stop and do some encapsulating, we would save 2 hours every time we add a report, and we add a report once a month, so we would save 2 hours a week or a month or whatever. You can then start coming up with math, and you can pretty soon justify going and spending 10 hours to refactor that function. But you can't say it costs 10 hours because that's what it would take to fix it. If it's never going to hurt anyone, you're never going to fix it. It's not real debt in that sense that you must pay back. You can keep your business forever on 30-year-old crappy code that's hard to read. People do.
Yeah, the problem is basically every time a developer tries to edit this function, he's afraid to do whatever with
That's
it.
right.
So basically, the best solution is copy-paste it.
That's right. They just follow the pattern from last time.
Follow what works. And it's very hard to convince somebody that basically if we break it down, or if we take 2 weeks to break it down, it will reduce long-term friction.
Right. And that's the arithmetic you have to show them. And the real problem with the arithmetic is not, you can make up any number you want. We'll save 2 hours every time we add a report, or we'll save 20 hours every time. Like, management can't really argue with whatever number you make up. What the problem is what you multiply it by. Because, believe me, I did not think any of the code I wrote was going to live as long as it wrote. Like, that's why we had the Y2K problem. So we're all writing code in the 80s with 2-digit years, because this isn't still going to be being used in 1999. Like, that's never going to happen. We just need, like, 2 character fields to hold the year in. And then, oh my gosh, they're still using this code, and it's 1999, and we have a huge problem, right? But in a sense, we're still doing that. You've got this thing that you have to add a report to, and people have been adding a report to it once a month for 20 years. And there are 250 reports, and that's never going to stop. There's going to be 500 reports soon. But management looks at your scheme for how to make adding reports easier, and they say, well, we wouldn't break even on that till you added 100 reports. So they won't go along with it. But you're like, we're going to have 500 reports, so we'll be ahead. That's the part they don't always see, is that long term, just how long this is going to go on for.
Thank you.
I would like to thank you all very much for your warm welcome, and I'm looking forward to spending the rest of the day listening to all the other speakers. Thank you.